All right, guys. So now we'll move on to the next type of proof. So we are learning several types of proofs when it comes to center of mass. So the next type of proof is, as you can see, we are going to find the center of mass of a lamina created by the finite region between two intersecting curves. So this is a different one. Do you see the difference between this and the previous one? The previous cases you had first we discussed about finding the center of mass of a lamina bounded between the curve and the x-axis. That was the first time, right? Because basically you found the area between the curve. I mean, the lamina was created by the area between the curve and the x-axis. But now you can see the lamina is created by two intersecting curves. All right, guys. So there are two intersecting curves. Okay, so let's see how it's done. So this is the example. First, I'll explain you the example, and we'll do one sum on our own as well, right? Okay, so over here, you can see the first curve is y equal root x. The curve that goes below, you have here y equal half. Okay, so the if you're going to do, I mean, we're going to use calculus and we're going to use the definitions and we're going to get the center of mass. So the definition says that you must divide the area into strips, right? So the strips each has a width of delta x and the strips are so small. Okay, so when you take the strips so small, each strip is equivalent to a rectangle. Okay, so that's how we do this. So you can see here I have taken, we take one general strip. I name it as PQRS and always the P coordinate. Now over here, guys, the thing is normally I mark the P coordinate as x comma y, right? I normally mark the P coordinate as x comma y, but over here you can see I have named the P coordinate x comma y1 and I have taken the Q coordinate. I have taken a special consideration for Q. The reason is because now, we are trying, we will obviously, now, PQR is the rectangle and I will be doing what? I will be trying to find the mass and the center of mass of this rectangle. So mass is proportional to the area. So if you try to get the area of the rectangle, guys, you'll see that in this case to get the area, because the strip doesn't go until this whole length, you don't just get to use the y1 length. Can you see? So this is where y2 comes into play. Can you understand? Because if you want to get this length, you can see this particular length should be y1 minus y2. So you'll have to introduce another person here. Okay, so basically I need the coordinates of both P and Q. But you can see both P and Q share the same x coordinate. The x coordinate doesn't change for both P and Q, right? They both share the same x coordinate. The y coordinates are changing. All right, guys. Okay, so now what we do here is exactly the same as what we did before. We will attempt to write the mass of PQRS and we will attempt to write the center of mass of PQRS. Okay, so first, can you all take a moment to attempt that? So write the area of PQRS and the center of mass of PQRS. All right, guys. So you can see here, first I've taken the area of the strip PQRS. So length into breadth. So length is y1 minus y2, right? The small length is now y1 minus y2 multiplied by the width delta x. And to make it a mass, you can multiply it by rho. So you can actually combine this into one step. Even though I've written this in two steps, you can directly write mass and directly write this answer, okay? The center of mass. So this is more of a challenge. Center of mass is exactly in the middle of the rectangle, right, guys? So how do you get the coordinate of the middle? So you can already see, remember when you're giving the coordinates, you're measuring and you're giving it with respect to the origin, okay? So remember you're giving the coordinate at the center of the rectangle, okay? So measured with respect to O. So you can see already we have the O to Q distance, that is X, and you have half of delta X, right? X plus half of delta X and the Y coordinate, guys. So you need the middle coordinate, okay? Not just the distance. So I think one of the most common mistakes that people do here is they write y1 and they subtract it from y2 and divide by 2, thinking that they get the coordinate. That doesn't give you the coordinate. That just gives you y1 minus y2 divided by 2. It just gives you this small distance. y1 minus y2 divided by 2 gives you this just this small distance. So that's not what I want. I am required to find the distance from the origin, from the O. Okay, I need the full y distance. Okay, not just the small part. Okay, so basically if you want to find that, the easiest thing to do here is to add and divide by 2, right? If you add the two y coordinates and divide by 2, you get the coordinate of the middle line. That's something you learn in P1. Add the coordinates and divide by 2 to get the midpoint, right? So y1 plus y2 divide by 2 gives you the midpoint y coordinate. Simple as that. Okay, and this is measured from the origin because it gives you the complete y distance from here the complete y distance. All right, guys. Okay, so from this point onwards, it's now time to do the time to apply the rules. And by the way, over here, you can clearly see there are no lines of symmetry. So you don't have any shortcuts. Okay. In the previous case, I didn't have to find the y bar, right? Because the semicircle was on the line of symmetry. But over here, there's no line of symmetry, which means x bar must be found separately and y bar must be found separately. Okay. So you'll have to apply the equations 2 times to find each of these two guys. Okay. So we'll first go for the we'll first go with the x coordinate. Okay, so shall we go for the x coordinate? Let's find this. So with the equation sigma mi xi equal total mass into x bar. So over here, once again, can I do any shortcuts for sigma, the total mass? Now you can see here the total mass is this area of the full lamina, but you can see that the full lamina area does not give a shape that we know, right? So it doesn't reflect a semicircle or a rectangle. The full shape is not a known shape. So in this case, we don't have any shortcuts. Okay, in the previous, if you recall the previous section, in the semicircle, the total mass. Okay, when it came to the total mass, sigma mi is the total mass. The total mass, we directly went for the equation of the area of a semicircle because the full area is something that we know. But over here, the full area is not something that you know. Okay, so it's not something that you know, and there's no line of symmetry, which means you'll have to do everything from the beginning. So you can see here that I am finding everything, right? Can you see sigma mi xi? So here mass multiplied by center of mass. Mass is y1 minus y2 delta x into rho and multiply with the center of mass x coordinate. Okay, so I'm first finding for x. Can you see? Equals total mass. Total mass is what? How do you get the total mass? Total mass means you add all the masses of all the rectangles, only the mass. So you can see here, I take y1 minus y2 into delta x into rho, only that part. And you take the summation. So if you take the summation of only the masses, you get the total mass. Can you all see? And then multiply by x bar. So x bar is what we are trying to find here. All right, guys. Okay, and then from that point, the next thing we do is as delta x limits to 0, the summation becomes integral. And so the summation mark becomes integration and the delta x becomes rho. Can you guys see? Delta x becomes dx. So y1 minus y2 rho times x times the delta x becomes dx. Over here the x bar, so that doesn't come inside the integration. Remember, x bar is a constant value, right? So x is a variable, but x bar is not a variable. Okay, guys, be very cautious about that. X is a variable because x is something that changes, but x bar is a constant value, the center of mass. Okay, then so x bar is not coming inside the integration sign. You have here y1 minus y2, the delta x becomes dx and the rho. All right, guys. And the next thing you need to be cautious here is, and the next thing you need to do here is actually you can see I still didn't write the limits because when you're doing the integration or the summation, you need to know from where to where you're exactly applying these limits, right? So from where to where are we applying the limits? You can see the x value start from 0, right? Very clearly you can see it starts from 0. But where does it end? Where do these strips end? You can see you keep on taking strips until this point where the two curves meet again, right? So you have to find this particular point because we need the limits. Are you with me? We need this particular value in order to get the limit, in order to apply the limits. So how do we get that particular value? You can see the place where we end is, it's the place where the curves are meeting. So basically solve the two equations simultaneously. Y equal half x is one curve, y equal root x is the other one. So solve them simultaneously. Just equate them. Simply equate them because both of them have the same y coordinate when they are when they intersect with each other. So half x equal to root x, and you can see I have simplified here, guys. I hope you can understand what I've done over here. So basically, I've just taken the x. The x is there here. Root x comes down as a division. The half I've taken to the other side up as a multiplication. Can you see? The 2 went up, the root x came down. So x divided by root x, in other words, x to the power 1 divided by x to the power half, power subtract, and you get x to the power half. Is that correct? Because these are actually basically P1 maths, right? So this should be really easy for you. And then removing the power half by squaring. So you square both sides and this becomes 2 to the power 2, 4. Oh, great, you square both sides, okay? And then x becomes 4, which means this point, the place where we end the limits, I mean, we apply the integration limits, or the summation starts from 0 and ends at 4. All right, guys. So over here, we apply the summation limit. As you can see here, we apply from 0 to 4. So these must be from 0 to 4. All right, guys. And then you can see here that I take the x bar. So you can say I'm kind of like getting a general equation. Rho is a constant which you can bring out of the integration sign. So inside the integration, you have y1 minus y2 times x with respect to x. And I brought this to the other side as well, making x bar the subject. Y1 minus y2 is inside the integration sign. The rho is a constant, so you can bring it out. The rows can cancel out. And you get this kind of like this final equation for x bar. Okay, so we are not done with it yet. You have to now perform the integration and actually get the proper x bar value. Okay, so let's continue with the next. Let's continue with the integration now. All right, guys. So after you come to this point, so we are not to find the answer for x bar. So we need to perform the integration. So what we need to do now is, your integration is done with respect to x. So as you recall, we need to substitute the y1 and y2 with in terms of x in order to perform the integration. So how do you substitute the values? So over here, guys, you can see how we input y1 and y2. Now you can see y1 is actually the y coordinate that's is representing y coordinates on the top curve. Can you see? Y1 represents the y coordinates on the top curve. So what's the equation of the top curve? You can see the top curve is y equal root x. Y equals root x. So basically, in other words, this is what we take for y1, because y1 is representing a y coordinate from this top part of the curve. So top part of the curve equation is y equal root x, which means I will use, instead of y1, I will use root x. And y2, what about y2? You can see y2 represents on the part on this line, right? The line that goes at the bottom. So basically, y2 represents any y coordinate that goes along here. So this is y2. All right, guys. So y2 is what we take as half x, because y2 represents the y coordinates of the bottom part of the curve. All right, guys. So substitute y1 is root x, y2 is half x. Can you see? So, so we are gonna let's perform the integration. So we'll take the numerator and denominator separately, shall we? Okay. So I'll separate it and do. So let's apply. So I'm gonna take the numerator first. 0 to 4, y1 was root x, right? Y2 is half x with times x with respect to x. Is that okay? Y1 is root x, y2 is half x with respect to x. Okay, and remember there's an outside x here in the numerator. Okay, so y1 minus y2 times x with respect to x. Okay, so before you perform the integration, yeah, so this is actually a P1 integration. So first you'll have to multiply inside. Root x into x is x to the power half into x is x to the power 3 over 2. Minus half x into x is half x square with respect to x. Limits are from 0 to 4. And then when you integrate here, x to the power, so when you integrate, you add 1 to the power and divide. Half, when you add 1 to the power, x cubed divide by 3. Limits are from 0 to 4. So this is 2 over 5 x to the power. Okay, so substitute, this is 2 over 5. So x becomes 4, right? 4 to the power 5 over 2. Minus half into 3, or half into 1 over 3. I'll directly write 1 over 6 into 4 cubed. Can you guys see? The other term, I think when you replace x with 0, everything is a 0. So get the answer here. What's the answer? This is 2 over 5, 4 to the power. So it's 2 to the power 2, 2 to the power 5, right? So 32. 4 to the power 3, that's a 64, right? So get the answer. What's the final value? All right, so this is 32 over 15. You can easily get that in the cal. And then the denominator is directly integration of y1 minus y2. Just y1 minus y2. There's no x over here. Okay, so just y1 minus y2 with respect to x. So y1 is root x, y2 is half x. So directly integrate. So root x is x to the power half. So when you integrate, you add 1. Half plus 1, 3 over 2, divide by 3 over 2. This is half x square divided by 2. And input the limits. Your limits are from 0 to 4. So this is going to be 2 over 3. 4 to the power 3 over 2 minus half into 1 over 2 is 1 over 4, 4 square. Minus x is 0. All right, so get the answer for this as well. Already it's 4 over 3. Okay, so then the next thing you do is, okay, so we have everything ready. Just substitute the numerator value and the denominator and get the x bar. So x bar equals, so the numerator value we got was 32 over 15 divided by denominator value we got is 4 over 3. So just simplify and get the x bar. So this is the value of your x bar. All right, guys. So you get here the answer 8 over 5. So this is the x bar. So we have found one coordinate. Okay, so we have found the x bar of this particular case, right? Okay, so we are not done yet. Okay, so that was just finding the x bar. But you know, in this case, there's no shortcut for finding y bar because there's no line of symmetry, which means what? Even y bar needs to be found. Even y bar needs to be found. So in this case, you'll have to again, now x bar is done now completely. So you'll have to go for y bar. So as you can see now, we apply again the center of mass equation. Sigma mi yi equals total mass into y bar. So this is the equation that we use to find the y coordinate. So you'll have to do this as well now. Okay, because in this case, both x and y are unknown, the center of mass coordinate. So you have no shortcuts here. So again, you'll have to do the same story. So sigma mi is the mass of the rectangle. So y1 minus y2 delta x into rho. So sigma mi yi. Guys, what about the y coordinate? So we found the y coordinate. Y coordinate of any rectangle is y1 plus y2 divided by 2. Can you see? So sigma mi into yi. Okay, equals total mass. So total mass is actually, in the sense, you have the total mass that you found previously. You could use that value, or else, okay, we'll just go with this now and we can substitute that value later. So total mass, you can, for now, for the equation, let's input it properly. So total mass is when you add the area of all the rectangles. So you have the area of one rectangle as y1 minus y2 delta x into rho, right? So you add the mass of all the rectangles. Can you see y1 minus y2 delta x rho, and you put the summation, which means we add all the masses of all the rectangles. And the summation limits are from 0 to 4, right? So as delta x becomes 0, summation becomes integral. Then you can see, so this is the, the summation has become the integration y1 minus y2 rho y1 plus y2 over 2 delta x becomes dx. Okay, over here also y1 minus y2 delta x becomes dx, rho comes out, and your integration limits are from 0 to 4. So guys, again, it's the same story, right? So again, it's the same story. So into y bar, actually I have forgotten, right? So this is total mass into y bar. Remember, y bar is a constant, okay? So it doesn't have to come inside the integration because it's the center of mass value is a constant. It's not a variable. Okay, so that's outside. And then you can make y bar the subject now. So when you make y bar the subject, I hope you guys can see the rho will cancel out, right? So you get here integration, the half, if you want, you can take it out. y1 minus y2 into y1 plus y2. If you guys can see, this is y1 square minus y2 square to make our life easier, right? Can you guys see? Because it's y1 minus y2 times y1 plus y2. A minus b, a plus b is a square minus b square. And this denominator too, I just brought it out as a half. Is that okay? And divide by integration of y1 minus y2 with respect to x. Yeah, integration limits are from 0 to 4. Guys, I think you can now see the numerator, of course, you'll have to find this. Okay, the numerator needs to be found, but the denominator, I think we already got it. Can you see? integration of y1 minus y2 from 0 to 4, that answer we already have. We already got that answer as 4 over 3. So that doesn't need to be found. The only thing you have to find here is the numerator. So this integration must be found. So get the numerator part. Only the, let's first find the integration. Y1 square minus y2 square with respect to x. Integration limits are from 0 to 4. All right. So let's apply the values and find it now. Okay, so I'll input the half here as well, right? Or else we might have a chance of forgetting this, right? So, okay, so you suggest me, let's put the half. Okay, so I took the full thing, then half times integration y1 square minus y2 square with respect to x. So what was y1? Y1 is root x, y2 is half x. So let's integrate. So y1 is root x, where y2 is half x square. All right, with respect to x. Root x square is x, half x square, that's 1 over 4x square. All right, guys. Limits 0 to 4. So half times, now let's go for the integration. So x integration is x square over 2 minus this one, it's 1 over 4. X square integration is x cube over 3. All right, guys. So your integration limits are from 0 to 4. So half into 4 square over 2. 1 over 4 into 1 over 3, that's 1 over 12 into 4 cube, right, guys? So that's the first part, minus the second part. When you replace x with 0, everything's a 0. And then I close the bracket because half is supposed to multiply with everyone, right? Okay, so when it's just a matter of typing in the cal, get the answer here. Okay, and then it's 4 over 3. So denominator, we don't need to find it, right? Because the integration of y1 minus y2 with respect to x, that was already done, right? Y1 minus y2 with respect to x from limit 0 to 4. The answer is 4 over 3. We got it previously. Right? Yeah, that was 4 over 3, right? Yeah, denominator answer 4 over 3. We got it previously. That's done. We don't need to find it again. So now let's find y bar. So numerator is 4 over 3 divided by denominator is also 4 over 3. Can you guys see? Numerator answer is 4 over 3, denominator 4 over 3. So y bar will be 1. Okay, so your y bar answer will be equal to 1. So guys, that's it. Okay, so you can see the full working here. So this is how you find the center of mass of a so this is actually what the lamina was filled by two intersecting curves. All right, guys. So this is how it's done. All right, guys. So I want to now attempt this particular question. So there is a better. I wanted to try to do this question using the theory that we just learned. So guys, over here also you can see this is an area that's bounded by two curves, right? Can you see? This is an area bounded by two curves. Now they say the diagram shows a uniform lamina occupying the finite region bounded by the x-axis, the curve y, and the line with equation y equal to x. Can you see there are two curves? Find the coordinates of the center of mass of the lamina. They're asking you to find the center of mass. Now guys, I know what we, most of the time, what we feel here is, okay, let's take the horizontal strips, right? Sorry, let's take the vertical strip. This is what we feel like doing, isn't it? But when you do like this, there is a potential issue now. What is the issue? You can see that if you take the strips in this manner, can you see that you are only concerning with the y equal 2x graph, and this does not have. Now you can see y equal 20 root 24 minus 4x is a completely different type. So if you take the strips here, these strips are going to go with y equal to x. Now, the theory that we learned previously, I think you saw in that question, right? So you saw in this particular question You had both y1, y2, when you took the vertical strips, you got both the curves under, I mean, you can see that you're touching the rectangle, has both those the curves touching. But can you see over here, there is a potential issue. The issue is that when you draw the, when you draw the vertical, I mean, the strip, it doesn't touch both the curves. Can you see it doesn't touch both these particular sketches? So if you take it in this manner, this is going to be an issue. So what you need to do here is, guys, instead of drawing the strips vertically, we will draw horizontal strips. Can you see what's the advantage in doing this? When you take horizontal strips, guys, can you see that you are in taking into account both of the curves? And you can see that when you're taking the strips in this horizontal way, you have both the curves taken into account. Okay, so over here, this is the correct way to do. The horizontal strips are going to make your life easier. All right, guys, so this is really important. So you can see I have named the strip now PQRS, and P coordinate, we'll take it at the beginning. So this is gonna be, guys, so XY, but the thing is this, now I'm going to, the thing here, I'm gonna take the mass, I'm gonna take the area, I'm gonna take the mass, I'm gonna take the center of mass. So when I take the area, you see now over here, when it comes to a horizontal strip, what's the width now? When we took vertical strips, the width was delta x, but now you can see the width is it's a y width, right? Because you are getting the width along the y axis. So the width in this case, it's not delta x, the width is going to be delta y, because you are doing a small change in the y axis, not the x axis. Okay, so this time the width is delta y. So guys, when you're taking the coordinates, p coordinate, you can take it as, how do you take, what's the best way to take the p coordinate? So what you can see here is, since we are going to take the area, and you can see we'll need the length, right? So to get the length, you can see I'm going to use x1 comma y. And you can see q coordinate will be x2 comma y, because you can see both p and q are sharing the same y coordinate. They are on the same horizontal line. The x coordinates are changing. So p has the x coordinate x1 and q has the x coordinate x2. So basically what I need here is, I mean, in order to write the length, I need these two values. Can you all see? So it's x1 and x2. So now we are ready. So after you kind of, get your head around this kind of a representation, so you can go with it. So first you can get the area. So area of PQR is length into breadth. So length is x2 minus x1 into breadth is delta y. Remember, when you subtract, you get the length between PQ, directly the length. We are not taking coordinate now, okay? We're taking the length, so subtract the Q, the x value and the x value of P. So then you get the PQ length only, okay? And then you, to get the mass of PQRS, you multiply by rho. This multiplies by a rho. Is that okay? And then get the center of mass. So center of mass of PQRS, so how does it work? You have to get the middle x coordinate. So the middle coordinate. So how do you get the center of the rectangle? The x coordinate, to get the midpoint, you add and divide by 2. Okay, remember, you add and divide by 2 because you're getting the coordinate. You need the coordinate measured from the origin. Okay, so that's going to be x1 plus x2 divided by 2. Is that okay, guys? You add and divide by 2. What about the y coordinate? So currently the y coordinate here, I mean the y distance to this point is y, and this small distance is delta y over 2, right? Because the small distance, so y plus delta y over 2. But delta y is so small, right? Y plus delta y over 2. Delta y is so small, divided by 2 is again, it's really small. Adding to y, it's negligible. So it's just y. Agreed? Y plus delta y over 2. Okay, so it's y plus delta y over 2, but this is so small that it becomes y. Okay, so that's what we use here for our center of mass. All right, so we have the mass, we have the center of mass, and by the way, for the total mass, do you think I can use a shortcut? The full shape does not look like anything that we are used to working. It doesn't look like a semicircle or rectangle or any shape. So in this case, you can't use any shortcuts. The total mass has to be found. It has to be done through the summation and the integration. All right, so let's go for the x coordinate. So mi sigma mi xi equals total mass into x bar. All right, guys. So sigma, and by the way, so sigma mi xi total mass into x bar. So by the way, when you're using the limits here, okay, I think we'll come to the limits in a moment. Okay, so mass is x2 minus x1 delta y rho, that's the mass of a rectangle, multiplied by center of mass, the x coordinate is x1 plus x2 divided by 2. All right, guys, so that is sigma mi xi equal to total mass is the summation of mass of a rectangle is x2 minus x1 delta y into rho. That's the mass of a rectangle. So summation gives you the masses of all the rectangles into y into x bar. All right, guys. And over here, I hope you guys can understand what are the limits. Now you can see delta y will actually become dy, right? As delta y reaches 0, summation becomes integral. Right? So we'll change this. Okay, so then this becomes integration x2 minus x1 into x1 plus x2 over 2. The row you can take out of the integral sign. Delta y becomes dy, guys. Delta y becomes dy. Here x bar is a constant. Doesn't come inside the integral sign. The row is a constant. Take it out. And here you get integration x2 minus x1 with respect to y. Can you guys see this? You can cut off the row since it's a constant on either side. And guys, you can see here you have now integration with respect to y. So y limits. So it's y limits. Okay. So basically, the thing is, I still didn't go for the limit. So basically, you are using y limits. As you can see, it's not the x limit. You don't use this x value and then find this. If you use the limits from 0 to 60, that's completely wrong, because you're assuming that you are doing this along the x axis. So we are doing this along the y axis, which means we need the y limits, guys. Is that okay? So basically here the starting y value is 0, ending y value, it's already marked here. Actually, we don't need to find. So they have given it as 4. Can you see? It's given as 4 here. So if this was not given, I would have to solve these two equations simultaneously and actually find the y value. Okay, so since it's given to me here, I really don't need to find. So my y limits are 0 to 4. So that's what goes here. Because in this case, we are doing this with respect to y. Okay, so my integration limits are 0 to 4. And guys, you can see I have now my x bar equation. So x bar is, you can take a half out here, integration x2 minus x1, x2 plus x1. Guys, it's a multiplication of two brackets. So it's x2 square minus x1 square. So multiply it. Okay, difference of two squares. I just took the half out. Divide by integration x2 minus x1 with respect to y. Limits are from 0 to 4. All right, guys. So this is now time to integrate. Time to integrate, but the thing is, your integration now happens with respect to y. Your integration now happens with respect to y. Therefore, x2, x1 must be substituted and written in terms of y. Is that okay, guys? So we'll go to our equation. So where do we get x1? You can see we get x1 from the first line, right? Because x1 is on the first line, y equal 2x, which means I can write y equal 2x1 because I get x1 from these points on this particular line. And I can write x1 is y over 2. Can you see, guys? X1 is y over 2. And the other equation, I get x2. I get x2 from this curve, y equal root 24 minus 4x. So we'll write that down, y equals root 24 minus 4x2, guys. All right, so I want to make x2 the subject. So removing this root, it becomes a square on the other side, equals 24 minus 4x2. 4x2 equals 24 minus y square. So x2 is 24 minus y square divided by 4. All right, guys. Or you can write like this, 24 divided by 4 is 6. Minus 1 over 4 y square. Is that okay, guys? 1 over 4 y square. Yeah. So we can substitute these values now, right? Yeah. So x1 is y over 2. So I'll go for the numerator first, okay? Half of integration x2 is 6 minus 1 over 4 y square. Okay, but you can see it's not just x2, it's x2 square. So my x2 value is 6 minus 1 over 4 y square. So that x2 should be squared. Can you see x2 square minus x1 square? So x1 is y over 2. X1 is y over 2. So that's y over 2 square. Guys, can you see? With respect to y. So this is the numerator, half x2 square minus x1 square. So it gets a little bit more complicated because you need to square it. All right, so you'll have to first, expand the brackets and, do a little bit of simplification before you go for the actual integration. So half integral sign is still there because we are not performing the integration yet. So expand the bracket here. This is 36. This is minus twice of 6 into 1 over 4 y square, right? That's how it goes. And then plus the square of 1 over 4 y square is 1 over 16 y to the power 4. Then in the middle, it's a minus mark. Now this minus mark doesn't get squared because this particular minus is not inside the bracket, right? So minus is outside. Y over 2 square is y square over 4. Close bracket with respect to y. So now add the similar terms. First add the similar terms and then let's integrate. All right, guys. So you can see that over here I have taken the common terms, added them together. Okay. And then after I got to this point where I added the y square terms, I went for the integration. So 36y minus 13 over 4y cube over 3, 1 over 16 y to the power 5 over 5 as we are performing our integration with respect to y. All right. So then we apply the integration limit. So you can see I've done it and we get 656 over 15. Okay. So that's the numerator. Now let's go for the denominator. The denominator will be integration of x2 minus x1 simply, right? With respect to y, limits are from 0 to 4. So x2 was 6 minus 1 over 4 y square. x2 minus x1. x1 is y over 2, right? Simply. Okay, so now we can, I think over here there's nothing to do much. So you can directly go for the integration. This is 6y, 1 over 4, y cube over 3, half y square over 2. And your integration limits are from 0 to 4. All right, so let's apply the limit 6 into 4, 1 over 12, y cube, that's 4 to the power 3, half into half, that's 1 over 4, 4 square. Minus, next you limit by input 0, so that's all zeros. Get this answer? All right, guys, so we have the answer 44 over 3. So I have my numerator and denominator, so just substitute and get the x bar. So x bar equals numerator was 656 over 15. Denominator is 44 over 3. And this gives us a x bar. So what's the x bar value? 164 over 55. 164 over 55 is the x bar. Okay, so this is half of the sum done. So now we have to also get the y bar. Okay, so similar to getting the x bar, let's also get our y bar by using the equation, right? Find the coordinates of the center of mass. So now to get y bar, what do? So we go for sigma mi yi equals total mass is sigma mi into y bar. All right, guys. So same theory again, limit 0 to 4. Mass is x2 minus x1 delta y rho. And y coordinate is simply y. Can you see? Because you have to multiply by the y coordinate. Can you see? So not only the mass multiplied by y. The y coordinate equals total mass is sigma, just the mass x x2 minus x1 delta y times rho, right? That's only the mass. And then multiply the mass with y bar. Don't forget the y bar. All right. So as delta y goes to 0, we know the summation becomes integral. So 0 to 4, rho can come out. x2 minus x1 times y equals over here. Also the rho comes out 0 to 4. x2 minus x1 times delta y becomes dy. Y bar is outside. All right, guys. So rho can be removed. And then you get here y bar equals x2 minus x1 y into delta y becomes dy, right? Over here, dy. Divide by x2 minus x1 dy. And your integration limits are from 0 to 4. All right, guys. So let's get the numerator first. Because denominator, if you recall, I don't need to find because denominator I have already found in the previous part. Okay. So I only need to do x2 minus x1 times y dy. So x2 is 6 minus 1 over 4 y square minus x1 is y over 2. And so the whole thing multiplies with y. So I get here 6 into y is 6y minus 1 over 4 y square into y over 2. That's going to be 1 over 8 y cube, right? Because we multiply with y. As you don't need to recall, I multiply everyone with this y, okay? All the terms. I'm multiplying with y, 6y, 1 over 4y square into y is 1 over 4. I'm sorry, not 1 over 8. This should be 1 over 4 y square, y cube. All right, guys, that's okay. 1 over 4 y square into y is y cube minus y over 2 into y is that's half y square. All right, guys, I expanded the bracket right correctly with y, 6y minus 1 over 4 y cube minus y square over 2. Okay, so we are done with that. Time to integrate now. So apply the limit 6y square over 2 minus 1 over 4y to the power 4 divided by 4 minus half y cube divided by 3. Limits are from 0 to 4. All right, guys, so apply the limits. This is going to be 6 over 2. That's 3 into 4 square. This is 1 over 16. 4 to the power 4. This is 1 over 6. 4 to the power 3. That's the first limit. So this minus the second limit is a 0. All right, guys. So what's the answer for the numerator? Okay, so this is 64 over 3, guys. All right. So denominator, I don't need to find because I've already done it. Okay. So denominator x2 minus x1 with respect to y 0 to 4. We've already done it previously and that answer was 44 over 3. So therefore your x bar, sorry, we are finding y bar now, right? So y bar numerator is 64 over 3 divided by denominator is 44 over 3. So what's the final answer for y bar? 16 over 11. So guys, this is the answer for y bar. Can you see? So this is the answer. Okay, so I hope you all understood how to do this part of the lesson, right? So this is where you draw the strips and where you have the area bounded by two curves. So make sure your strip touches both the curves. Okay, otherwise the strip, it does not become successful. So you need to make sure your strip covers both the curves in order for this method to work. Okay, so I hope all of you understood how to take strips vertically when necessary and also horizontally when necessary. All right, guys. So I hope everything is clear until this part.